Welcome everybody, and thank you to the survey for asking me to make this presentation, and thank you Ming for a great introduction because it leads very nicely into my presentation. And I should point out that my presentation is based on the work that was done by one of my graduate students, Kate Pearson, who's now been married and her new name is Bizarro. And she completed this a few years ago, and we actually got most of what I'm going to talk about today published in the AAPG bulletin. The reference is down the bottom, so if anybody wants some more details on this work, then you can get the paper from the AAPG bulletin and also from her master's thesis, which was published a few years earlier. Now, I'm mainly going to focus on the Goddard today, both some work that we did on the geochemical characterization of the shale and also the oils that were being produced from the Goddard. And this is interesting because, as I'm saying in this introduction slide here, that a lot of times if you ask people what the major source rock is in the Anadarko Basin, the automatic response is the Woodford. And as we saw from Ming's presentation, this obviously is a very prolific source rock, but I think it was very useful that Ming pointed out that there are a number of other source rocks there in the basin that are often overlooked. And from a geochemical perspective, we can actually differentiate between these different source rocks and also the oils that are being produced from the different source rocks. And as I just said, we're going to primarily focus on the scoop play today, both the oils and some of the samples of the Goddard that we had the opportunity to look at. And one of the big conclusions that you'll see from this study will show that the geochemical data indicates or shows that the oils, a lot of the oils in the scoop do not have the classic Woodford signature, and in all probability have a significant source contribution from the Goddard. Now, this is probably the first of many times that you'll see this particular map today, and I'm sure everybody knows where the scoop is, the south central Oklahoma oil province. And most of the Goddard production is coming from the Garvin, Grady, and Stevens County, as illustrated on this map. I should point out as well, though, that as part of other projects that we've been undertaking in the geology department over the last several years, we've been doing quite an extensive study on both the stack oils and the scoop oils. And we have a total of 172 oils that we've looked at from these two plays that are illustrated on this particular map. And although we're only going to talk about the scoop oils in this particular presentation, we are in the process of preparing publications on the stack oils and talking about their characteristics and their potential sources. So that's something that will be coming out in the relatively near future. And Ming's already covered some of this. And as we see on this stratigraphic column here, the Springer Shale of the Goddard, Mississippian Age Shale, it's the basal unit of the Springer group. It's an unconventional mudstone overlaying the Caney Shale. And then, of course, we got the Sycamore Limestone, and we get down into the Woodford Shale just a little bit deeper. Over the years, with my geochemistry group at OU, we've done a lot of work on, well, both the Woodford and the Caney, the Viola, and these other formations. And we've published a lot of that over the years, particularly in the late 1990s and early 2000. And Ming had mentioned some of these studies that are listed there on the left-hand side. Some of these studies were sort of fairly extensive surveys of both the oils and the source rocks, and looking at some of the different characteristics of these source rocks and also the oils. And obviously those studies were done some years ago, and we've got a lot more new information on the characteristics of the oils and the source rocks from these different locations now. And so as I mentioned previously, we're basically going to look at both some characteristics of the source rocks, primarily looking at the organic richness, maturity, Rock-Eval data to see the oil and gas potential, and also some of the biomarker data. And similarly with the oils, we'll be looking at the biomarker data. And again, this isn't the place where I can give you a long, detailed explanation of what we mean by biomarkers, but basically these are compounds that are present in the oils and the source rocks that are derived from functionalized organic compounds that were deposited billions of years ago when the source rocks were being first formed. And those functionalized compounds have since been converted into hydrocarbons. And we can look at the distribution of these hydrocarbons to get information about the source materials, depositional environments, maturity, migration pathways, level of biodegradation, and so on. And this is something that was initially developed back in the 1970s and has continued to develop since that time. And we still find new compounds in oils and source rocks today that we can use to assist in providing additional information on the origin and the history of the oils. And probably most of you are familiar with the Rock-Eval data these days. It's providing us with an indication of the total organic carbon of a source rock, the richness of the source rocks. Tmax is a parameter that provides us with information on maturity, can be correlated with vitrinite reflectance. And the hydrogen index is another widely used parameter from the Rock-Eval data, which gives us information about the type and potential of organic matter in the source rock. And then the biomarkers, as I just mentioned, these are present both in the oils and the source rock extracts and become very useful, not only for getting the type of information that I just mentioned, but for undertaking oil to oil and oil to source rock correlations. Now these, what you see here is are the samples that we had access to in the initial stages of this investigation on the Goddard. And I should point out again that when Kate was doing this study, she was doing it in the very early days when the scoop was just being emerging as a significant play. And it was very difficult for us to get a large number of oils. It was even more difficult to get core samples. So in some ways, we were sort of fairly limited by the sample set that we had. But again, I think we came up with a fairly good story here, which I'm going to share with you now when we look at some of the results from these analyses. So, So we had 11 oils and 15 core samples. She also got an outcrop sample and an asphalt sample, which was also recovered from an outcrop. But both of those turned out to be sourced from the Woodford or had Woodford oil in them. So we're not going to talk about those two samples today. And here's a map showing, again, the distribution of those source rocks and oil samples. The source rocks on this map on the left-hand side obviously are the SR samples, the oils are the OL. So fairly sort of limited area within the scoop in Grady and Stevens County. But again, since Kate did the initial study, we've expanded the number of oils that we've looked at in this area. And we haven't seen any significant differences in terms of the distribution of the organic compounds in these oils from what we were seeing in this initial study that I'm talking about here today. I should point out that Tasmanides are also always thought of as one of the major sources of organic matter, primarily in the Woodford. There are a couple of photomicrographs here that were provided by Brian Cardot a few years ago. On the left-hand side is a picture of Tasmanides in a Woodford outcrop. And then on the right-hand side, where it's one of the Goddard source rocks that we looked at. Again, the abundance in the Goddard is somewhat lower, but the Tasmanides are definitely present in the Goddard. It's also interesting, and again, these are pictures that Brian provided us with, that there is, I should say, some evidence of fusinite in the Goddard samples. And fusinite is a maceral, which is typically associated with terrestrial input and the occurrence of forest fires. And So we'll see in a little bit later that we also found organic compounds that are present in the Goddard, which support this observation of the contribution from the terrestrial source material and the presence of forest fires occurring at that particular time. Just a few words about the Rock-Eval Pyrograms. Some of the source rock samples that we looked at here, we used the conventional Rock-Eval approach, which is where you basically see an S1 peak, which is equivalent to the extractable organic compounds that are present in the source rock. Then the S2 peak is are the components that come from the breakdown of the kerogen itself. And so there are other compounds that or other peaks that you'll see in the Rock-Eval, but I'm just going to focus on the S1 and the S2 peaks today. The other samples, the other source rock samples we had analyzed at the French Petroleum Institute, where they have a slightly different way of using the Rock-Eval parameters or getting the Rock-Eval data. Their S1 peak is split into two peaks, so-called S0 and a S1 peak. And basically, the S0 peak correspond to the free hydrocarbons that are present in a rock sample. And the S1 peak that you see here, or SH1 as they refer to it, these are the sorbed hydrocarbons. And so when you get, this is also equivalent to saying when you're getting production from a shale, the free hydrocarbons will be produced more rapidly than the sorbed hydrocarbons, because these have to become desorbed before they can be actually produced. And then the S2 peak is the same regardless of which approach that you're using. So it's just a slightly different way of getting the Rock-Eval data, gives you a slightly little bit more information. So you see on this table that the 6 of the samples of the Goddard source rock samples were characterized using the conventional Rock-Eval. And then the samples at the bottom here were analyzed at the French Petroleum Institute using their modified Rock-Eval method. Now, a couple of things to point out here. Most of these samples, or virtually all of them, are fairly mature. You see, well, here are the Tmax values, but Tmax, as you probably know, can be converted into a vitrinite reflectance equivalent value. And you see most of these values are around 0.9 to 1.1, almost 1.2. Also, the hydrogen index values. Now, we're not going to talk about this first sample because this is one of the outcrop samples, turned out to be a Woodford sample. But you see the other ones, the HI values are relatively low. But you have to, when you look at Rock-Eval data, you can't just look at the HI values and say these values are low. You have to think about, well, why are the values low? Well, the values are not low because of the TOC, because if you look over here at the TOC values, most of these values are in the range of anywhere from about 1 up to over 7%. So TOC values are good. And so again, you have to ask yourself, well, why are we seeing low HI values with good TOC values? The answer is in the maturity, because as the maturity level increases, so the HI value will decrease, because remember, the HI value is based on the size of the intensity of the S2 peak. And and the S2 peak comes from the kerogen. As the maturity level increases, so the S2 peak will decrease because you're generating hydrocarbons. So when you do this HI versus OI plot, you see the majority of samples are plotting down here. They're still showing up as type 2 kerogens, but they have relatively low values. But again, that's what they're looking like today. If they got high values today, high TOC values today, and they are mature, then you know that before the maturity level got to 0.8 or 0.9, whatever it is today, and they were initially formed, those samples would have been plotting up here, showing that they had very good oil potential. So let's look at some data now related to the organic matter, both in the rocks and the oils. And again, I know probably a lot of you are not geochemists and you're not that familiar with looking at these chromatograms. The thing is, if you're not, then just think of them as fingerprints. I'm not going to go into detail of what all these organic compounds are. I'll tell you something about them. And the fingerprints are reflecting the distribution of these different families of organic compounds. So these are simple normal alkane chromatograms showing the distribution of the normal alkanes, ranging from alkanes that have got about 10 carbons out to about 30 in this region, from a couple of the oils. Pristane and phytane, these are branched hydrocarbons. They become very useful to get information about the oxicity or anoxicity of the depositional environment. And then this is showing one of the source rock extracts. You lose the lower alkanes in a source rock extract because you have to evaporate the solvent. And when you do that, you lose the lower carbon numbered compounds. There's nothing really significant to say about these chromatograms. On the next slide, I'm going to show you some ratios that are derived from the pristane and the phytane, and also the interpretation. This is a very widely used diagram. It's showing the ratio of pristane to C17, that's the normal alkane, plotted against phytane to normal C18. And the black diamonds are the rock extracts, the open circles are the oils. Two things to notice. First of all, these samples are all grouping together fairly closely. That's suggesting that the oils have a common source. And at this point of the discussion, it's also suggesting that they're probably derived from these particular source rocks. You shouldn't depend upon these data alone to say that, and we've got some more data that will support it in just a moment. And also you can see that this diagram can be divided up into these different zones, and it's basically telling us that the organic matter that was responsible for the formation of the Goddard was deposited in a fairly reducing type environment, and almost certainly a marine type environment, because, when we go over here, you see these relatively low pristane to phytane ratios, which again are generally reflecting a fairly anoxic or at least suboxic environment, and typically a marine type depositional environment. Nothing surprising there. We know that now from other information as well. So basically, just to quickly summarize the Rock-Eval data, this is showing that the rock samples have a good TOC content. The hydrogen index values are relatively low, but that's because the samples are relatively mature. The GC data, the chromatogram data with the alkanes and the isoprenoids indicates a marine source of organic matter deposited under relatively reducing conditions, favoring good preservation of the organic matter. Petrographic data supporting the presence of varying amounts of Tasmanides, relatively low abundance of terrestrial organic matter in these samples. Now here are some more chromatograms of a couple of oils. They're not biodegraded at this point because you can see all of the normal alkanes are present. However, if you notice down here, we've got a relatively high abundance of these lower carbon numbered normal alkanes. And that's suggesting that in all possibility, there has been a second charge of non-degraded lighter oil mixing in with these oils at some stage. We don't know what the source of that condensate is. We don't see it in all of them. We just see it in a few of them. But there are definitely indications that mixing has possibly occurred in some of these samples. There are a lot of diagrams that you can plot when you're looking at oils based on lower carbon numbered compounds and higher carbon numbered compounds. This is a typical so-called Thomson plot after the geochemists that developed it. This is a plot of the ratio of toluene against normal heptane. It's a C7-alkane against heptane to methylcyclohexane. And basically, these parameters will change as a result of various processes, such as evaporative fractionation, maturation, biodegradation, and so on. But basically, all of these Goddard oils that we looked at were plotting down in this region, which is a fairly normal region for these for normal oils, suggesting that there hasn't been a lot of alteration occurring to them. Now, this is where it gets a little more complicated, but basically what we're looking at here is the distribution of some biomarkers. Basically, this is a typical crude oil chromatogram, and hidden down here in the baseline of the chromatograms are the more complex compounds. One family of biomarkers are the so-called terpanes. This is a typical terpane chromatogram. As I said, there's no time to go into telling you what all those compounds are, and we just have to use this as a fingerprint for the present time. But when we look at the classic Woodford biomarker fingerprints, and there are several here, this is the typical terpane fingerprint. The steranes is another one, where generally in the Woodford, C29 steranes are more abundant than C27 steranes. And another very characteristic feature of the Woodford is the presence of these compounds, which are called Arylisoprenoids. And they're associated with green sulfur bacteria, and they've got carotenoids, C40 carotenoids in them as well. And in all the studies we've done to date on different source rocks in the Anadarko and Ardmore Marietta Basin, we never find these compounds in anything but the Woodford. They're not in the Viola, they're not in the Goddard, they're not in the Sycamore or any of these other source rocks. So those compounds are very important. Now here's the key thing though. Here we're looking at an extract from the Goddard and an extract from the Woodford. These are the same, the technique used to get these two fingerprints is exactly the same. And I think even if you're not a geochemist, you can see that these are very different fingerprints. And that's telling you right away that almost certainly the Goddard has a different fingerprint than the Woodford. And this particular fingerprint, I must tell you, is a fairly unusual fingerprint on a worldwide basis. You don't see a lot of areas where rock extracts or oils are dominated only by these tricyclics. Most samples also have the hopanes present in them as well. And when we look at an oil from the Goddard or from the Scoop area and also compare it with the source rock, you see the similarity there. This is a classic oil source rock correlation where you're looking for similarities to say that two samples are related, or in this particular case, to say that this oil was almost certainly generated from the Goddard. And as I said, this type of terpane distribution is relatively unusual worldwide. This is just a summary of other places around the world where this has been seen, but in all of those cases, the source rocks are typically dominated by Tasmanides, but it's a fairly unusual distribution. Just a few other fingerprints supporting this idea that the oils are coming from the Goddard, sourced from the Goddard. This is the sterane distribution from the Goddard extracts. Here's from the Woodford. Now, to many of you, that may not look like a very big difference, but what we're saying is that in the Goddard, the C27 steranes are more abundant than the C29 steranes. In the Woodford, it's the other way around. And this is a very reproducible difference. This isn't just some random observation. And it's reflecting a difference in the source materials that are present in the Goddard versus those in the Woodford. I mentioned already that the Arylisoprenoids, and this is the finger for the Arylisoprenoids, are present in the Woodford, But when you look for that same group of compounds in the Goddard, you don't see them. This is a totally different family of compounds that we see when we're using the same technique to analyze the Goddard as we used up here to analyze the Woodford. So that's a very significant difference between those two samples. This is another family of compounds. These are called Sesquiterpanes. Again, I'm not showing you the structures of these compounds because we're just looking at the fingerprints that we've obtained for these different families of compounds in one of the scoop oils, from a Goddard extract, and from a Woodford extract. And you can see here the scoop oil and the Goddard extract have very similar fingerprints. Then we compare it with the same fingerprint obtained from a Woodford extract, and obviously it's quite different. So again, the biomarker data, which is, for those of you not so familiar with it, this is a widely used technique worldwide by all the major companies and a lot of other companies these days, is showing very strongly that in all probability, a lot of the oils in the scoop play were actually sourced from the Goddard. I mentioned earlier about the petrographic evidence showing the presence of fusinite in the Goddard, and how that's indicative of combustion and forest fires occurring at the time of deposition. Well, here's some chromatograms that are showing the presence of this compound, which is called benzopyrene. Again, we don't need to worry about the structure of that, but this is a compound which is an indicator of combusted organic matter typically produced as a result of wildfires. And as you see here,
I'm sorry to interrupt. You've got about 5 minutes left. Just giving you a
heads up. Okay. I got 2 more slides, I think.
You're fine. Go ahead. Okay.
So this is showing the distribution or the presence of benzopyrene in one of the scoop oils and in 2 of the source rock extracts. So again, this is just an example of where we use very specific compounds to indicate different sources of organic matter. And just seeing I got a couple of minutes extra that I didn't realize I was going to have. Here, this slide I showed you previously was just to briefly explain how the distribution of these steranes is being used to show differences in the source material. We can also use various ratios derived from different sterane components within these chromatograms to get information about maturity. The ratios will change as a result of maturity because some compounds are more stable than other compounds. And also, if the oils were heavily biodegraded, some of these compounds would start to be removed in a very systematic manner. But in these samples, there's no biodegradation. But I just add that in for those of you that are not so familiar about what we do with these compounds that are called or referred to as biomarkers. So there we go. In summary, I think the marine nature of the organic matter in the Goddard has been being confirmed by the geochemical data. Most of these samples have maturity values in the late oil window. The TOC values and the HI values were also reflecting this maturity level. There may have been earlier episodes of biodegradation followed by a second charge of a more mature condensate. And the terpanes, the family of terpanes in the oils and the source rock extracts were dominated by this rather unique distribution of tricyclic terpanes. And these were very useful in showing that correlation between the oils and the Goddard rock extracts. And so the final bullet there at the bottom is that it would appear that in the scoop area, the Goddard is certainly a very significant contributor to the source of the scoop oils.